Thank you all for coming. My name's Charles. I'm the Chief Product Officer here at Temporal, and we're really happy to have you all for this conference. And I'm particularly looking forward to this workshop. I've been at Temporal for about a year, and from my time with the user community, the type of interaction that I see between the user community and folks at Temporal, that's sort of the richest and most interesting is when we're talking about design and architecture, because Temporal winds up getting inserted as part of some larger stack. We have a lot of implications in terms of different design choices you can make and like what different things you can potentially do with the programming model. And so there's these sessions that we'll do one-on-one. Dominic's done a bunch of them. When I started Samar, had a bunch of these. Tio's done a bunch of these, where it was commonly the case is someone would say, hey, I've been building this Temporal application or service. I'm kind of halfway in. I would really appreciate it if someone could kind of look over my shoulder and give me some feedback on some of the choices I'm making or some of the implementation decisions. Who's willing to do that? And then there'd be this kind of hour-long conversation that would happen afterwards, and it would feel like everyone, we learn a lot from it. Temporal, we wind up learning things that make the product better. And it tends to make for better software that people have written with Temporal. So I'd always wanted to do something where we did this more as a group setting as opposed to one-on-one, because I think there's so much good learning that comes out of it in terms of how you think about designing applications with Temporal. So this is our first attempt to do that. And we got 3 intrepid volunteers from the user community to be a part of that, and we'll get into that in a moment. And then we have 3 fantastic panelists here from Temporal who have had a lot of these conversations in the past. So the plan for this workshop is I'm going to introduce the panelists. I'm going to ask them a few questions just about the basics of how you think about design in the context of Temporal. And then we're going to have different users from the user community who are maybe at the beginning of the process of building a Temporal service or feature or application, or midway through, or maybe they've already got something in production, but they think they'd be worth discussing kind of what some of the design choices are they've made, and are those the right ones, or what other alternatives could they have considered? And so we'll have each one of those folks share a bit of what they're working on. It's going to be very informal. It's going to be just kind of here's kind of what I'm trying to build and why. And then the panelists will be able to ask questions and then make suggestions. For those of you in the room, if you're curious about the advice the panelists are dispensing and why it's good advice or not, or questions about the application, we have this great Slido Q&A. So while the panelists will be giving feedback or kind of asking questions and making suggestions on what folks are working on, I will be monitoring the Slido, and I'll be interspersing questions that if you guys have. So that way we can get all of your input in from the audience. So please do take advantage of Slido. I'm going to pull that up momentarily. While I'm doing that, why don't I start with introductions, and maybe I'll just kind of say the name and then say a little bit about yourself. So Dominic, why don't you start?
Hey, I'm Dominic. I'm super happy to see everybody here today. I think I had lots of interactions with many of you. As Charles said, that is actually the favorite part, my favorite part of the job is interacting with the community. So please do feel free, do it now. Yeah, reach out to me on Slack. I'm on Dominic. Reach out to me, and then we schedule a one-on-one session, half hour, an hour, as long as you want, as long as you need. So I'm part of the DevRel team here at Temporal. I do a lot of the design and architecture session. And yeah, my background is systems modeling, conceptual modeling, formal modeling, and yeah, principal engineer. So I'm super looking forward for this session as well, just as Charles. Thank you.
Thanks, Dominic. Samar, you want to say, this is Samar Abbas. Do you want to introduce yourself?
Yeah. I'm Samar. I'm like one of the co-founders for Temporal. I'm a developer first, and like super excited, by the way, to see all of you here. I've been doing hacking on this problem for over a decade now, I've been doing these kind of sessions, understanding the kind of challenges a particular engineering team is facing, and then figuring out ways how we can solve that through the platform that we are trying to provide. Each and every feature, and I say that a lot, each and every feature in our product, I can tie it to a real outage in my past lives. And we are here because of the reason we are able to build this amazing community around the product. So super happy to be here, and then hoping for an amazing discussion about all sorts of problems.
Fantastic. And Tio, would you like to say hello, introduce yourself?
Yeah, sure. Hi, everybody. My name is Tio Shurdilovic. I've been at Temporal for a little over 18 months now. I am part of the support team. And yeah, one thing that I personally love about Temporal is the passion that we have for our community, for our users, for all of you. They're asking the questions on the forum, Slack. If you're not, please join and make sure that you ask anything. It comes from people that are just starting off with Temporal to people who have been using it for a long time. And somebody from our company, our team, is going to be more than happy to help you and work with you to resolve the questions. And yeah, that's it. Thanks for being here.
Wonderful. So before we get to I promise we won't do too much with just Temporal people. We want to get to the actual specific applications, but I did want to do at least a few things just to kick the conversation off with the panelists. And there's kind of two questions I'd love your guys' take on. Sort of one is, when you meet different individuals that are building features or services with Temporal, what's the most common design problem, design challenge, or kind of mishap that you tend to encounter when they've committed to building it in using Temporal? And maybe to start with Dominic, I'd be curious to get your take.
So one super interesting observation that I'm continue to make is, if you think about workflow or function or process, we usually think about this behavior, something that starts and then something that has an end. And when I joined Temporal, that was how I was thinking about workflows. It's a process, it's a business process, right? And it runs to completion. And Temporal, in the context of business processes, already makes fantastic guarantees, because you can code your business process as if time limits do not exist, and as if failures, platform level failures, do not even exist. But it took me a little while to realize that if I only think about a workflow as something that has a beginning and an end, then I actually don't do this concept justice. Because the workflow can also represent not just a process, but an entity. And if we think about it, everything in life, everything in business has these two aspects to it, right? There is a process aspect to things, but then there is an entity aspect to things. So, for example, if you think about an order, right? An order goes through its different process execution. But a workflow execution also can represent an entity. It can act as an actor. And just like anything in real life, the truth is somewhere in between. You will see that a lot with workflow executions. So I see a lot of very successful workflow executions if you embrace both of these aspects. And you can see that oftentimes there is a kickoff phase. So workflow execution kicks off and runs a little. And then you're entering sort of a loop where you're basically just reacting to signals and to queries, where the entity aspect is more in the foreground. And then some action happens, some signal, and then you move into another phase until you go again into more of an entity aspect. So if you combine the capability of workflows to both represent processes and entities, then I think you get the most out of this core abstraction that Temporal provides.
Thank you. So Mark, the same question to you. If you think when the most common kind of thing you see people solving for when they first made the decision to incorporate temporal? What's that architectural design challenge they were typically solving for? And then once they kind of invest in building it with temporal, what's the most common misunderstanding or pitfall that you see folks wind up in?
Yeah. So I don't think there is like one pattern out there. Like temporal itself, at a very high level, it provides this concept of durable execution. And it's just like amazing that people keep on finding usefulness of that pattern for all sorts of different applications. One of the good things about like bringing temporal into your existing application is it's not like a all or nothing. I have seen small things as back at Uber, there was a team like who's processing a message from a Kafka topic, and then they need to make a banking API call, and the SLA provided by that bank was 3 days. And apparently, like they can be down, and if that event happens over a weekend or a long weekend, no one is going to look at it until the entire long weekend. So that's why the banking system provided an API, like if we are giving you a failure, keep on retrying that for 3 days. So Kafka is a good technology choice, but definitely not the technology choice where you want to retry a message over 3 days, and because it blocks your cursor essentially on the topic. So for that particular team, they came up with a problem that, oh, we have this existing architecture. We know it's not scaling because of this particular semantic that they require of retry logic for 3 days. So they adopted temporal for just that use case. That like, oh, when they get an error from a banking API, they would kick off a workflow, and it's just like a single line with a retry policy on it. Oh, if you get an error back, keep on retrying until you can push that message in. And so that's how that particular team adopted temporal for their use case. But slowly, they keep on discovering other benefits of like other use cases within that particular team. And slowly, they keep on ripping out different Kafka topics and then replacing bigger parts of their end-to-end processing through a workflow system. So sorry for the long answer, but no one pattern. It's about bring your problem. Like you need to have a very concrete problem, and I'm sure in this durable execution primitive could become a very healthy, like could become a solution for solving that problem in a much cleaner way.
Very helpful. And then one last question for you, Tio, kind of just to focus on, when you talk to lots of, for those of you guys who don't know, one of the things that we do at Temporal is we actually have a support team that just supports the open source user community. Because we find that there's like the documentation, the way to kind of learn about the concepts of the product. In fact, there's training later today. But then you get halfway through a project and then you got a question. And so we found that it's really helpful to have people to reach out to in line. And Tio and a small team at Temporal do that. And so in that context, Tio, I'd be curious, when you think about all the users you interact with, most common kind of implementation pitfalls, is there any like one way to think about things or pattern or thing that you're like, this is the anti-pattern people always seem to wind up in?
Yeah, so one thing that we do see is Temporal is completely unintrusive when it comes to frameworks, when it comes to the ecosystem that you want to use, programming languages and things like that. So from the community side, we see everything. We see people having existing applications that are introduced in Temporal 2, or we see people, they're completely starting new development efforts and starting off right away with Temporal. I think with any technology, when it comes to workflows where you represent your business logics, the most important thing is that you can represent it, number one. And number two, that you can represent it in a meaningful way, not only that it executes, but then you can scale it up as you need. So from the user perspective, what we see is everything. We see people use Temporal in many different situations. As far as best practices goes, there is definitely best practices. And if you look at our forum, we oftentimes we have a user ask us some sort of question, and we ask him, hey, can you please describe your use case a little better? And that way we can improve or give him some advice as far as some best practices goes for using Temporal. Usually these best practices apply across all of the SDKs that we have. So best practices can be applied by multiple people regardless of their frameworks or programming language or even things like that. So yes, we do have some anti-patterns too, just like with any sort of technology. And but typically, we haven't encountered yet a case where we say no, you cannot do this with Temporal. Typically, we are able to provide some sort of solution that best fits the particular user who has the question, but also can be applied across a large number of users that have a similar problem too.
Very helpful. Thank you. So what I want to do then is two things. I'd like to ask Tony Galata to come up. And while Tony gets set up and I'll introduce him properly, while he's getting set up, I'm going to drain the initial Slido questions that we've accumulated from the audience. Please keep them coming. And I think also as we get into specific implementations and examples, there'll be more. So I'll do that while Tony's taking my chair. And then I'll introduce Tony. So, Tony, is that okay? Yeah. Cool. All right. So the first Slido question was, how do you pronounce Temporal? Is it temporal or temporal? And this got 5 votes. Probably more in the way. The story of the name Temporal, well, Max and Samar came up with the name, and neither of whom are, Max is not originally an English speaker, and so he's like, well, what's the pronunciation? And everybody would colloquially kept saying temporal, and so that's kind of what stuck at the company. The correct English pronunciation is temporal, and I fought it for the first 6 months I was at the company, and then they shamed me into now consistently mispronouncing it as temporal. So take that for what you will. If you value the Queen's English, then it's still temporal. Don't let some vendor's marketing agenda get in the way of that. But if you want to kind of signal that you know what's what, then temporal. That's the mispronunciation is what we've embraced. But it is that.
Yay for temporal.
Yeah. Case in point.
Yeah.
Okay. So Tony Galata was kind enough to volunteer. By the way, everyone who did this is a total trooper. Normally we do these sessions in small, like one-on-one, two-on-one type of things, and so it takes a lot to share your work in progress with a large audience. And we intentionally kept the tax of doing this very low, so it's going to be very informal from what Tony comes with, but I think we're still going to be able to generate a rich conversation. And I'm really excited to start with your company, because who could not like where you work, which is
TAC.
Is a reservation system that's sort of been eating away at OpenTable and Resi and live in San Francisco that Talk is the gateway to. And I can only imagine where there's kind of roles for workflows there. So do you want to maybe share a bit about kind of where you're at the company and the kinds of things that your team works on?
Yeah, so Talk was acquired by Squarespace last year. Squarespace website builder tool, much larger company. But Talk is still pretty small. We're around 200 employees and about 30 engineers. So we just started a platform team a couple months back that I'm leading. And we started using Temporal for a couple of things. We've been running it in production for 2-3 months now. And yeah, I can get a bit more into some of our use cases.
Yeah, I'd love to start with that. So what sort of, well, actually, let me start with this just at the beginning. So it's a relatively new platform team, it sounds like, yeah?
Yes. Yeah.
What was the charter? What do they say you guys were supposed to do that was different than what they'd done before?
It was kind of up to us to figure it out, but the idea is kind of to build shared infrastructure that can help the development teams deliver faster and better features.
Besides temporal, like what are other examples of things like that?
So actually our first project was to build a solution for what we were calling asynchronous tasks. Basically long-running user-facing tasks that were taking over a minute or two, and we're just, we were doing them by HTTP, and it was a bad experience. So we looked at, we're in Google Cloud, so we looked at their kind of task solution, and it was not going to work for our use case. So we considered building out systems with like a task queue and a processor, and then we found temporal, and it seemed like a better fit.
So we wound up being actually the platform team's first project just coincidentally wound up being temporal, essentially.
Right.
All right, very cool. With that in mind then, so can you share a bit about the Talk application and sort of where these async processes tend, I mean, I can kind of guess, but like where these async processes tend to be prevalent, and what was your first kind of guinea pig for where you wanted to insert temporal?
Yeah, so is my screen visible at all right now? I do have some slides, but
Can we flip to the... Huh. Thank you for... It would be great if we could... There we go. Wonderful.
All right.
Now it's gone.
It's as soon as you went into presentation mode, it blanked like this. How about what? What's that? So we should just get out of presentation mode is the answer? Oh, mirror.
I am mirroring. Let me try switching to separate and going back.
Oh, yeah. Do you have the power on?
All right. Well, if we drop out of presentation mode, this works. Oh, wait. We almost had it. Oh, it almost came again. Oh, hallelujah. All right.
Okay. Yeah. All right, we've got it. Okay, so the first use case we have, this is the only one that's in production right now. This is the long-running tasks I was talking about. So we have a case where the business goes and configures what kind of reservations, et cetera, they're going to offer on Talk. And it can take us a long time to process that update. So we switched that over to temporal. And basically, instead of one HTTP request, now we're just polling for status updates to the workflow. We don't have any queries yet, but we would like to add some queries in to tell them more about the progress we're making on that request. And then we have some reporting requests as well that we're taking over a minute or so that we've moved to workflows. I feel like we kind of want to use it for everything. One of the things for us is we're trying to break down our Java monolith right now. So another use case we're working on is to break emails out of that monolith and send them in TypeScript, where we can kind of share some of our templating libraries with our UIs. The big use case is new e-commerce flow that we're working on. We want to use Saga patterns here, and that's the one I'd like to get into a bit further. We also are really interested in using scheduled workflows to replace our current solution for distributed cron.
Oh, fantastic. One question before we proceed. So I feel like a lot of times platform technologies get stereotyped. People kind of build a conventional wisdom about what they're good for or not. Right now at Talk, what would you say the conventional wisdom is about like when a developer is reaching for temporal?
Right now, it's along our first use case. It's long-running things.
So if it's long-running async, kind of the conventional wisdom is that's a temporal thing to do.
Right.
Very cool. Do you want to get into the architecture?
Yeah, let's do that. Our architecture is we've got exploretalk.com. That's our consumer-facing site. We've got a Java monolith we call the API server that serves HTTP requests to it. Most of our data is in a MariaDB database, and then our Java monolith talks to Temporal, which there are then 2 worker processes. So one dedicated to those emails, and then another Java worker process that is processing every task queue at the moment. And we're using managed Cloud SQL Postgres from Google to back Temporal.
And you mentioned this Java monolith. Is that the primary language for? Okay, no, you said
It
it's
is,
TypeScript.
yeah.
Okay.
Our UIs are TypeScript,
Oh, it's
and
just
our
UI.
backend's Java. So.
Okay, so it's a Java backend, and then this basically all the features that you described in the previous slide kind of follow this kind of a pattern effectively.
Right. So they're all kicked off. The API server Java monolith is the thing that's starting all the workflows, and then the worker process is processing all of them.
I got it. So basically, even though you kind of described a bunch of different features or areas previously, you can sort of think of each one as like you're peeling off something from this larger edifice of Java, and bit by bit, it's kind of making it into this temporal layer is effectively what's going on.
Yeah, exactly.
Okay, that makes a ton of sense.
I see 2 arrows, like one to the MongoDB. This is, sorry, MariaDB.
Maria, yeah.
And the other one is temporal server. So it looks like the monolith is making some database updates and also then starting a workflow.
Yes. So that MariaDB database is kind of our core data store where just about everything is. We have secondary databases, but the temporal workflows are also interacting with that MariaDB database. I just didn't draw an arrow to it.
So one thing that we typically recommend, I don't know like whether it's doable for your architecture, is make temporal workflows. Any database update should be through temporal workflows. So like, because otherwise you have to solve race conditions yourself. Like making a DB call and then starting a workflow causes all sorts of MariaDB calls from the workflow itself.
Makes sense.
Level architecture before we get into the order processing.
Right.
Okay,
Makes sense.
let's do it.
Cool. Here's just kind of a code snippet from our order processing workflow. So we're using the Saga class from the Temporal SDK, and we basically we try to execute this Saga. We have a couple of steps that can happen afterwards outside of the Saga that we don't care as much whether they succeed or fail, like sending an email notification or something. One question I had on here, it might be early to get into this, but something I feel like we've struggled with is how we handle kind of client versus server classes of errors. So like what might be a 400 something in an HTTP response versus 500. Some of our workflows, we just throw an exception if there's a client error. Other ones like this one, we return a result that indicates that it was a failure, but we actually mark the workflow as a success.
So when you say client versus server error, so actually, okay, stepping back.
Yeah.
From a Temporal, one of the key primitives that Temporal provide is workflows never fail. But at the same time, we ask people that, oh, there is a lot of error handling code when people are implementing their workflows. So the reason that contradiction exists is when we say workflows never fail, we are talking about all sorts of infrastructure failure. Like while your workflow is running, your machine goes down. You don't care about those kind of failures within your workflow logic. But at the same time, there are certain business level failures which can happen that, you have an activity, and that activity, let's say, return an error that order not found. That is a business level failure. Temporal as a platform, handle that error. So that's the typical high-level guideline. In this particular case, can you provide more information? Like now having that guideline, can you provide more information? Like what does a 400 or 500 failure means?
Yeah, let's go into the details of this workflow a little more. So The actual steps in the saga are, the first thing we do is we need to, so this e-commerce application is specifically for selling bottles of wine through Tock. So one of the things we need to do first is we have a third-party service that will tell us if this wine can be shipped to this particular customer, if it meets all the legal regulations,
This is the
et cetera.
best temporal workshop ever.
Yeah. Now I know why Charles is excited. Yes.
Yeah, so we do that, and then if everything's good on the shipping front, then we proceed to charging the customer. So one of the things we were trying to do here is first do the things that are easiest to undo. So first we'll do that legal check, then we'll process any gift cards, because that's just marking a row in our database. And then the next thing we would do is go out to Braintree to actually process credit card payments. This could tell us that we can't actually ship to this customer legally and we need to turn down the order. A credit card might not be authorized, it could be rejected. That would be kind of a normal failure in this.
Yeah, so are you modeling, now coming back to your question, like all of these sounds like business level failures?
Yeah, definitely.
Yeah, and coming back to your original question, which was around 500 classes versus 400. The things that you are describing, I don't see you modeling as 500, for instance.
Right, yeah, so I think one of the things we did in our first couple use cases is if there was kind of one of these expected failures, client errors, we would still just throw an exception and fail the workflow. And that it's been kind of a challenge with our alerting, particularly because we alert on the workflow failing metric, and then we see that these are kind of expected failures. So one of the things we're doing in this order workflow instead is on our output object, we just mark it as a failure, and maybe we'll provide some more details about it, but we would still allow the workflow to complete successfully.
Yeah, I think that's the right thing to do. So, but where is these exceptions or errors originating from? Like, for instance, let's pick one case that you are not able to charge the credit card. So do you have an activity which fails and then you bubble it up?
Right.
And so do you control that activity?
We do, yes.
So which means that you have, I think probably Tiho, you might be a better person. Like we have ways where an application error can be returned back from a Java activity, right?
Yes, so
Can you talk about that pattern there?
Yeah, sure. So number one is Temporal has a number of set activities. For example, activity failure, child workflow failure. And these failures can propagate from activity execution to workflow. When you have a domain-specific failure, let's say he has a 404 exception that you throw in your activity, this will actually be able to propagate back to your workflow code as an activity failure, and your original exception or the domain-specific action, a failure that was actually thrown in your code is going to be included. So inside of your workflow code, you will definitely be able to know exactly what failure happened during your activity execution. And the cool thing about Temporal, this also works cross-SDKs. So for example, if you had an activity that was written in Go, that activity failure with the original cause of the actual failure that was written in Go, and you can catch it, for example, in your workflow written in Java. So yes, you can definitely propagate domain-specific failures.
So I think
the
key question here is, what is the recommended practice when application level failure needs to, we do not want to have a retry policy by default applied to it.
Oh, okay.
Yeah, can you talk about that?
So by default, Temporal does take the approach that, for example, activities do have automatic retries. These retries are going to happen with a default retry policy, which you can set through the configuration. So one thing you can do, two things actually. If you don't want this application or domain-specific failure to cause retries, you can either through configuration, through retry options, set the maximum number of retries to 1. Another thing that you can do in your activity code, you can actually specify that this failure is a non-retriable failure versus a failure that should be retried in some cases, if you say. But you also, through the configuration, you don't have to actually set that in your application code, but you can set it through configuration even in your client level. So you can say for this particular activity, this type of exception should either cause workflow failure even, or allow the default temporal way of actually blocking the execution, retrying the workload task, and allow you to fix the workflow that's currently running, and so you can keep executing even in case of this failure. Does that answer your question?
Yeah, I think so.
I don't want to bore anybody with talking more about failure, but I just want to say that we actually just released the first blog post in a series where we talk more about failure handling, and failure transparency. So more blog posts and more videos are coming up. And if you're interested, we can have an impromptu discussion about failure and ideal failure handling for your application later in the afternoon. So if you want, come find me. I will be downstairs and we can do an impromptu session. But what I definitely want to say here in the large audience is that if you look at temporal right, temporal will challenge how you think about failure. Okay, because today we're thinking about failure as on error, retry, 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 give up. Right? But temporal will challenge that notion and will motivate you to think about on error, retry, retry, retry. Don't give up. Repair your workflow. So don't fail the workflow. Repair the workflow. You can treat a workflow that is in a continuous retry loop as being suspended. You have a chance of going in there and fix whatever is currently preventing the workflow from making progress. If it is an application level failure, then usually you do not wait. Right? If a credit card gets rejected because of insufficient funds, yeah, we have a chance of maybe waiting for a month until the user makes another deposit, but usually we don't. That is an application level failure where we say we do not retry this. We actually give up and treat it as we could not make the payment. But other failures, like for example, certificate expired, which happens to all of us, happens to the best of us, no matter what processes we have in place. If your business logic actually allows you to wait 8 hours or allows you to wait 24 hours, do not fail that workflow execution. You may have thousands of these workflow executions that actually block on the certificate. Fix the certificate. And then on the next iteration, all of these thousands of workflow executions will just make continuous progress. That will challenge how you deal with failures in your application.
Yeah, I think Dominic is making a very good point. Workflows never fail. And although we do provide primitives like reset, which allows you, like in certain cases, if you have bugs in your logic, which causes your workflows to fail due to some missing error handling logic, you can go back in time and then reset those workflows after fixing that bug and then replay those or rerun those from that point onwards. But ideally, you should be thinking about all those business level failures, including your code bugs also, and rely on this temporal behavior of continuously retrying until those error situations are mitigated. So temporal changes the concept of what people think about what are transient failures. Transient failures in the temporal world could even be situations where people can roll out a new deployment to fix a code bug.
Awesome. When this was all just from this one question about a 400 versus a 500 error, do you want to jump back into the implementation? And are there other questions, or was that the?
I think that's the main idea. We didn't have a ton of questions on
it's
this,
fine.
but we would love to, if there's any other suggestions, questions about this workflow, we'd love to hear it too.
Wonderful. No, this has been great. I have a bunch of questions from the audience too, so let me kind of cycle those in. They're mostly well, anyway, you'll see. So we'll go through each one of these individually. So number one question: how do we keep long-running, years or decades long-running workflows without having lots of if-else blocks to handle all the possible workflow versions? Samar, you want to take a stab at that one?
Yeah. So actually, a very interesting question. So we are all about long-running applications. Versioning and making changes to an application which is stateful and lives for weeks, months, or years, it's a very hard problem. There are very few platforms out there that solve that problem in a clean manner. Today, we provide like a versioning primitive. Looks like this person is kind of hinting towards it's an amazing primitive which allows you to patch your long-running applications without doing any kind of backfill. So let's say if you have an application which runs for a month, and then you discover, and then you start millions and millions of executions for that particular workflow. And then you discover a bug in your workflow logic which triggers on the 29th day of running that application. Now, how do you patch all of those millions of workflow executions which have been in flight and not hit that code path yet? So this versioning primitive is actually an awesome way where you can patch all of those millions of workflow executions who has not hit those if-else blocks to keep all of those version branches alive in your code base. The technique that we typically recommend is to use continue as new. And we have seen, like, especially for entity workflows that Dominic was recommending earlier, which lives forever. One of the approaches that we typically did, like, pick a time duration, like a week, that every week all of those workflows do continue as new and migrate or move all of the state that workflow cares about as input argument to the new run of that workflow. And with continue as new, we provide a primitive where you can even do continue as new to a new type of workflow if you choose to. And the thing that it provides is now you have a guarantee in your system that you have no workflows which relies on any implementation which is more older than a week. So then you can basically go and then start deprecating all that, remove all that branches from your workflow executions which are older than a week. So continue as new is actually one of pretty good technique which you can manage that complexity.
Wonderful. I want to
let me add real quick. So Alexandra Lee, an intern at Convoy Tech, she just yesterday or the day before dropped a blog post about testing the compatibility or backwards compatibility of temporal workflows in the context of a CI/CD run. And I tweeted about that blog post today, and I just dropped the link to the blog post into the Temporal Slack at the water cooler channel. Check it out when you get a chance. It's a really cool post.
Wonderful. So what I wanted to do, I just realized I should take some of these questions a little out of order because I want to get all the talk questions in. And then we have a queue of other questions which are more general. So what I'm going to do is I'm going to kind of go a little out of order, take the talk questions first, then we can give Tony back the next hour. We can go through some of the general questions, and then we'll move on to the next application. So that's kind of how we'll flow. And with that in mind, let's see here. I want to do some grounding questions for talk. One is, what's the physical deployment architecture? So for example, are the workflows running on in one place or on many nodes?
It's in Kubernetes. We are running multiple worker processes.
Very cool. And then another kind of baselining question was, is your Saga, would you characterize it as orchestration or choreography? Sort of a trick question, I guess. But
I guess.
But I think it's worth
Yeah, I
mentioning
guess
for
I'd
other
ask
reasons.
what the difference you see between orchestration and choreography is.
And enter Dominic.
So, 3:20 this afternoon. Please be here. We're going to talk about orchestration and choreography. Officially the best event of the show. This is not an officially endorsed statement.
All right. Yeah, so it's the kind of first level education. Downstairs, Dominic is doing a talk, and one of them is on choreography versus orchestration, which is not unique to, that's not even specific to sagas. It's sort of like more of a general design philosophy that you can kind of pick one route or the other, and it has meaningfully different implications for your application. But I don't want to spoil Dominic's presentation, so I would just say check that out.
And Charles, I just wanted to add for people, we've been talking about Saga when we're looking at Java SDK. The Java SDK has out-of-the-box little small implementation of Saga or compensation, but with Temporal you can implement the same pattern in any SDK. So I just wanted to mention that there is a particular class here called Saga that you've been using in your code, but regardless of the SDK that you use, that will be very simple to implement a compensation of inside of your
Just on
workflow
that point, really
executions.
quickly, like show of hands, like how many people are familiar with Saga? Just to say, decent fraction. But some people not. It's okay. Raise your hand if you're like, what's a Saga? Anyone? What's a Saga? All right, that's enough that we should talk about this. All right. Dominic, do you want to start with kind of like the basic explication of a Saga, like just generically independent of temporal? I think it's really worth, because it comes up a lot.
So, and now I'm going to be repeating some of that at my talk later. But in broad strokes, a saga is a sequence of steps, just as a workflow is a sequence of steps. Now, there is sometimes the notion that a defining criteria of a saga is also the presence of compensating actions. So many times when you read about sagas, you will read about compensating actions. That is because not always do we have the luxury that we have transactions. Now, what's a transaction? A transaction is a sequence of steps that ends in exactly one commit or exactly one abort. If it ends in a commit, it is as if the transaction, if every step in the transaction happened and as if you were the only one on the database. And if it ends in an abort, it is like it didn't happen at all. Now, if we don't have transactions, we do not have that. We do not have the luxury. That system does not come out of the box with what we could call a rollback. Therefore, we have to code that on an application level, right? That is the compensating part. That is true whether you use a Saga pattern or whether you use the workflow pattern. So in our workflows, and as Tiho said, we have in the Java SDK a specific class for that. In the workflow, you keep track of the actions that you took. If in case you want to fail the workflow and roll back the workflow, you can then basically unwind or rewind the changes that you already made.
So just to add a little, put it in the context of talk in the kind of earlier part of the presentation. So Saga, for all intents and purposes, tries to accomplish a lot of the similar things to what a transaction would do at a database level. But you can essentially do it across a much broader scope of domain and services. And the story of talk is a classic example of where you see these sagas where there's this checkout and you would sort of think of it simplistically in the past and say, oh, well, this checkout, it's just like debit something, credit something, or like register an order, and like it's a single thing that happens that you update a database, or maybe you can kind of count on a transaction in a database to kind of verify that. But if you listen to the description of the use case for talk, there isn't just like order, it's also like, well, can I, is the person in a state there they can buy this wine? There's, are they over 21? Or like, there's all these other conditions which are not really just about, do you have money and here's your product? And that's super common, I find, with all these things that used to seem like just simple database level transactions, like move money, receive order, things like this. These days, these applications, you're doing 7 or 8 things in the process of just taking that order and moving that money, because there's a fraud check, or there's some marketing thing that's being served, or there's some regulatory thing that's being verified. And these other things are not typically in the same service backed by the same database as the other parts of the process. And so sagas wind up being a way of giving you a transaction-like experience to lash all that together so that you get sort of similar behaviors, that you want this entire sequence of things to happen, or if something goes amiss, you want it to unwind, which is a little bit like what transactions would have done in a database. So that's kind of what sagas do generically. And then temporal, as you can imagine, if you kind of think about the behavior of a workflow in temporal, sounds a lot like a saga, right? So essentially what you can think about is in temporal land, the happy path of a saga, everything happening in a specific sequence, is kind of just a workflow, or however you implement it. What sort of the library is really like saying, yeah, but what if halfway through my workflow something goes wrong? How do I unwind it? How do I compensate and get back to my original state? And the library is sort of, which is I think predominantly, is only in Java right now, which is something we need to resolve, but it's basically a convenience to make it easier to implement the compensation side of it. So sort of imagine like happy path of a saga, you sort of do that all the time in temporal. That's just the nature of building a workflow. When you say, no, it needs this whole unwind idea, and then it's an all or nothing. Sorry, I apologize, because the voting is throwing me off in terms of finding the last of the talk questions. Okay, so one is going back to the discussion of failure. So just to clarify, if there's a business logic failure, say charging a payment failed even upon retries, the workflow execution on temporal should still be labeled as successful, correct? Edit, this is already answered. Damn it. All right, sorry guys, I'm doing this in line. So your physical architecture, sorry, there's one other talk question. Hold on. If not, I'm gonna let Tony head back.
All right.
Let me see, I thought there was one more. Hold on. Yeah, I think we'll wrap them. We have a lot of generic questions, but I don't want to keep you up. We don't need to.
All right. Thanks, everyone.
Thank you, Tony.
There's one thing I would like to draw attention to, because happened to me, and I see that happening a lot, also when I talk to our users in the ecosystem. And that Tony mentioned, oh, we were looking for something that is long-running, right? We were looking for something that supports long-running processes. And then Tony also mentioned that in their context, it's about 2 minutes, right? And then other users, I hear, oh, it's a month. Other users, years. And for some, it doesn't have an inherent time limit, right? So long running is a very broad spectrum. So that actually raises the first question, is what is a long-running process, right? And a long-running process is, by my definition, a process that doesn't have an inherent time limit and should execute as if failure does not exist. Now, Tony also mentioned something else, that after they specifically chose temporal for long running, then I believe you said, oh, now we want to use it everywhere. Why is that? Why do we want to use it everywhere? That is because temporal actually successfully elevates the most fundamental yet most powerful abstraction that we have in computer engineering. And that is just a function execution. But function executions have weak execution guarantees. All right? A function execution is usually subject to a time limit, and it's also subject to failure. If the underlying process, the underlying container, the underlying node ceases to exist, that function execution ceases to exist. Why do we want to, once we have it, use temporal everywhere? because it's still just a function execution, but with strong execution guarantees. It's a function execution that executes as if time limits and failures do not exist. That is why it is so wildly adaptable, as Samar said, that there is no specific use case for a temporal workflow execution, because there is no specific use case for a function. It's a very fundamental building block.
Very good. So what I want to do is use, yeah, please, yeah, add one more.
Sorry, one more thing.
Not at all.
Yeah. One observation, Tony, I made is like you are into is like searchable attributes. You can have your own state, your business level state, rather than relying on the workflow status definition for temporal, like how we think about the states of a workflow. You should be able to have your own business level state for your business process, and you should be able to use that with searchable attributes to say, oh, give me all the orders which failed because of this state. So then your workflow still succeeds, but you rely on using searchable attributes. You can get a very nice behavior of finding all of the workflows which are not succeeding based on your own business criteria.
Yeah, very good point, and good advice. So what I want to do is, there's a lot of great questions that have bubbled up in Slido, but they're kind of orthogonal to any one application. So I want to get through at least like the top 5 of those in the next, I don't know, 10, 15 minutes. And then after that, we have another member of the community, Atish, that's going to talk about another application. But I think we want to kind of get through some of these while they're being voted up. This one, actually, I'd like to take, if it's all right, because it's sort of connected to a past life for me. Can you contrast and compare temporal versus Airflow? This is like heavily voted up, and it's a common question, so I'm happy to tackle it. So temporal, because of the centricity of workflow, will oftentimes get contrasted with a lot of other things that use that word workflow. So it's perfectly understandable. It's our fault for picking a word that is already used in a lot of other contexts. And we could have a whole other conversation. Actually, Tio, if you guys came from like a BPMN style mindset of workflow, Tio is your guy. He knows more about that world than you can imagine, and he can kind of help you understand that. But I spent 9, 10 years in data at Cloudera, so I saw my share of workflow, Airflow style workflow there. Let me try to draw the contrast. So there's a number of products, Airflow, Dagster, Prefect. I'm embarrassed my own connection to Uzi, but another one still. That are really like workflow engines that were designed to coordinate either kind of data pipelines or machine learning pipelines, something where there's some combination of model training steps and data movement and data manipulation steps. And all of these products, Airflow and others, they're kind of designed to facilitate that, to kind of march each of these jobs or queries or model training steps through a specific order. And usually everyone in the context of an Airflow or something, this will talk about a DAG, which is a directed acyclic graph, right? Which just kind of means like typically a pipeline starts, then there's it kind of branches out in a bunch of ways, and then usually like there's some idea the whole thing kind of ends and converges. Temporal, you could also use temporal to implement a DAG-like thing. So at one level, what you can do with temporal and what you can do with something like an Airflow, like at some fundamental level, like you can implement the same thing. If you want to write a really sophisticated data pipeline with like whatever 35 steps, that's going to run for 36 hours, or typical kind of like long complicated data pipeline, you can totally do that with temporal. You can totally do that with Airflow. However, there's actually meaningful differences in functionality and constraints. So I would argue that in terms of fit for purpose, they're not really the same. So in the context of temporal, what you get is, one, it's entirely code.
Whereas, if I'm not mistaken, while there's lots of language bindings in Airflow, fundamentally there's a DSL. Like there's a DAG-like configuration language that you use to express the DAG, right? With Temporal, there's not. The ergonomics of Temporal is everything is software development. So it's just the logic that you implement using the SDK, but there's no DSL. You're just writing code. So the user experience is different as far as like the development model goes. Because of that, what that also means is that your level of this is sort of if you wanted to use Temporal, the level of expressiveness you can have with Temporal is arguably better. You can kind of, you're not limited to a DAG. So you can kind of have things happen in whatever order or sequence you want in Temporal. You have more flexibility in that regard. However, most data pipelines, DAG is kind of is the correct answer for like 95% or 90% of the situations. So while you can be more expressive in Temporal, it's questionable how valuable that really is when you're just implementing data pipelines. Whereas, if you think about something like Airflow or their contemporaries like Prefect or Dagster, what they have going for them is they are much more purpose-built for data pipelines. So in terms of libraries for like connectors for different database types, or like hooks into Spark or Ray or other runtimes, there's just much more of that ecosystem built out in these products like Airflow and Dagster than there is in Temporal. So if you want all the extra functionality specific to data pipelines that you can kind of get in an Airflow or a Dagster, it's a perfectly good reason to use those and in lieu of Temporal. So I'd say these products are much more fit for purpose for data and AI pipelines. However, if you think about the types of features and applications that we've been talking about with Talk, I would argue that no one would seriously attempt to try to use Airflow in that context. So as soon as you're talking about business, I do get Max all excited. Let me wrap this up and then Max can jump in. But as soon as you're talking about business processes, sagas, long-lived processes, application logic, business logic, back-end services, Temporal winds up being a much stronger fit for that than these DAG-based tools, regardless of if it's Airflow or if it's Prefect or something like this. Temporal has, now all of a sudden, the fact that you have an all-code interface or experience matters a lot more, because all the rest of your business logic is being implemented in code too, so it kind of makes sense that your orchestration or your tasks are represented in code as well. And Temporal operates at much, much greater scales. So normally in data pipelines, you might think about hundreds or thousands of pipelines a day. With Temporal, you can think about hundreds of thousands of workflows a minute. So it's completely different orders of magnitude of scale when you start talking about executing business logic or executing these sort of sagas or doing these transaction processing style use cases. So that side of the world, I would say Temporal is a much, much stronger fit. On the data pipeline and ML and AI pipeline side of the world, my argument is it's much more it depends, and it's what you're optimizing for as a user and what makes you the most productive. Yeah, Max, do you want to add something?
I think just from feature point of view, it's worth mentioning a couple of things. Is that DAG by definition is static. So just basic thing, execute an activity, get number of partitions, and execute, for example, branch of your pipeline per partition is not possible with DAG. Yeah, you can generate DAG upfront, but anything dynamic doesn't work. I think this is important to understand. And another important feature, which I don't know if you kind of how all familiar with Temporal, is like what we call entity workflows. So you can have a workflow which practically sits there and waits for signals and reacts to them, or takes action. Like practically you have, I don't know, cluster, or like data set, and you can have workflow managing the data set and living forever. Kind of twin, digital twin of that. Similar to IoT devices, right? Temporal good for IoT device because you can have a digital twin, like a workflow sitting there and waiting there and managing the device. So in a lot of cases, and depends, data pipeline is not sequence of steps. Data pipeline is sequence of stages. The same applies for CI/CD very frequently. Practically, it's not like, oh, you execute these 5 steps, because you have this stage, that stage. This stage, for example, takes every check-in. This stage runs every hour. This stage runs once a day. This stage runs when you do release. And what you can do, you can have a workflow representing every stage and always being alive, and then pass the data around them. So if you think about that way, like you cannot do it with DAG. And DAG is just sequence of steps, or maybe parallel steps. But you can model your kind of ML pipeline, like not pipeline in this case, but pipeline, or your data pipeline, or your processes as a bunch of entities, like actor type, like other way to think about it is durable actors. And then they communicate to each other through signals or activities and can react to the world. So I think this is the biggest difference for me in the programming model. It's not that they certainly have integrations and stuff, which we don't. From other point of view, as soon as we have Python SDK, I'm pretty sure anyone can take a day and just write adapter to run any, I don't know, Airflow action as activity. I'm pretty sure it won't be a lot of code to write. But I think is think about your model. Like, especially I did CI/CD a lot, and CI/CD was that, don't think CI/CD is sequence of steps. Think CI/CD is sequence of pipelines, like stages, and every stage is an always running entity. I think this is the biggest difference.
Thanks, Max. Yeah, and by the way, on that same point, what is striking is if you look at temporal, where you find it more commonly, like you'll see Airflow a lot in the data pipeline side. But so, for example, we have a lot of use cases with like content pipelines, right? So like, whatever, there's like images or videos, and there's some like encoding they've got to go through, and then there's some like licensing that's got to be attached or what have you. So it functions very much, and CI/CD, as Max mentioned, is kind of another example. So those kinds of things, in those situations, like the kind of ecosystem of data stuff doesn't have as much value, and so you tend to find temporal in more of those places. Okay, next question up. If we have workflows written in a language, in this case Go, what is the best practice to share input or output types with clients written in other languages, being Python or TypeScript, so that they can easily execute the workflows and assign the result with strong types?
Yeah, we actually do have an example of that, and I think we can share it probably after the demo. Basically, yes, so we do have an example, for example, where you have a struct in Go, and it is input to your activity or result of your activity, and then you can pass it, create a class. Basically, let's say you have a Java data model class that has the same structure. Basically, all data inputs and outputs to workflow execution or results of activities or inputs to activities and child workflows are serialized basically with temporal. So through this serialization, which is common, basically serializing to JSON by default, or you can write your custom data converters to serialize and deserialize the particular data that you have in your application. You can accomplish that you can basically have a strongly typed way to communicate across programming or SDKs that temporal provides.
Protobuf as well.
Thank you.
Okay, perfect answer. Okay, next one. How could we prioritize same workflow for different use cases with different priorities? For example, in requests, if no normal ones. I've heard this one before too. So
is on task queues. At the end of the day, all of these workflows, the way they make forward progress is we dispatch a task, what we call as workflow task. Majority of the applications out there, they use a single task queue. And then have a single pool of workers polling tasks from the task queue. Because of that model, and then we today do not provide any guarantees around like any like first in, first out, or like any ordering guarantees on how we are dispatching tasks to those workers. So we hear this request a lot that I have different types of workflows. And one workflow is more important and needs to be executed in a faster manner. Like when a system is working normally and there are no backlogs, it doesn't matter. But typically these kind of things matter when you have a backlog in your system. When you have like hundreds of workflows which are waiting to be executed. But there are certain higher priority workloads which needs to be processed before draining the entire backlog. Our recommendation typically is use different task queues. If you know there are certain workflows which needs to be processed, they are higher priority than rest of the workload running within the same namespace. You can have a dedicated task queue with a dedicated pool of workers which are pulling things from that task queue. And that is typically one of the recommendations that we provide. It works well if you have no number of those. If you know, oh, I have a pool of high priority workflows, medium priority, and low priority. This does not work well if you have very large number of those priorities. In that case, probably we want to introduce a concept of priority when you are starting your workflows. So task queues inherently aware of, oh, this is a workflow task, which should be prioritized over others in the cases of backlog.
Yeah, so that we kind of have, like, what you can do today is the somewhat more crude version of, like, if you have really, really important things, and then, okay, if it's this coarse grained is like really, really important and everything else, then using, or something a little, maybe something a little more complicated than that, then the kind of mechanism that Samar is describing works pretty well. But if you want like more like weighting and, you know, all the typical kind of like workload prioritization type of features and techniques within a single queue, that's not currently a feature that exists today, but probably will in the future.
But one thing just to add is you have control of this yourself. If you want to implement fine-grained control of the order of execution of things, oftentimes you can implement it as a workflow, and you can yourself define, as far as your business logic, which child workflow should be executed before the other. So one way we kind of see people use it in the community is they have kind of like a workflow that receives requests, which are, let's say, each signal that it receives is an execution or an order to execute some particular workflow, and you can build in your own business logic inside of this workflow which one should be executed before the other. So a lot of times, even though there is some features that we're still adding or working on currently with workflows in general and temporal, you can take this requirement that you have in your business logic, it's still implemented while we're hard working on the back end to add the features that you all are asking for.
That's really helpful, thank you. And Tio wins the Turtle All the Way Down award for the workshop. Cool, let's see, your next question. Okay. All right, I want to do this in a slightly different order. I'm going to three more, and then we're going to go to Atish. What is the logic behind the limited retention period for completed workflows? Is there a way to use the workflow service to access completed workflows long-term, 3 to 12 months?
Like Archival is a feature which is available in open source. So first, right now, you need to understand the concept is when a workflow is executing, there's certain state which associates with a running workflow, which is its entire execution history, and another thing that we call as basically the mutable state. Because we use event sourcing and the execution history, actually that's the dominant part of the state that we maintain for a particular workflow execution. After a workflow completes, we keep all of those things around, especially on, and there are certain use cases where people want to keep closed workflows around for very long duration of time. Sometimes one of the key cases that we hear a lot is around compliance. So that for those kind of cases, we build archival as a feature, which is what it does is like gets rid of all of the state on the hot store, like Cassandra, MySQL, or Postgres, whichever adapter that you are using, and to free up the more critical resources and pushes all of that state into some kind of a blob store for cheaper storage. And our recommendation for those scenarios where you want to keep workflow data for much longer periods of time for compliance or other business needs is to use archival for that.
Very cool. All right, 2 more questions, and then we're gonna transition over. So, one, I'm gonna mush 2 questions together, which are both about workers. And the first question is around, let's see, make sure I get this right. What's the general recommended strategy on configuring and scaling workers? Say if all the workers share the same resources, does it even make sense to have multiple workers? First question. And then nearby, there was another question, which is, have you ever considered supporting workers running as serverless functions? For example, using push-based tasks to be executed by an AWS Lambda function instead of a constantly running worker. So I thought that'd be good to kind of take those 2 together.
So yeah, so maybe I can take an attempt at it, and then probably Tio and Dominic can fill in. We are not opinionated when it comes to how you want to deploy your applications. But these workers, by the way, are completely stateless. All of the state is managed by the server. And although these workers do maintain caches of active workflow executions, and it plays a little bit of role in the performance characteristics of a system. But like a lot of time, I have seen people have come up with dynamic auto-scale policies on how using our schedule to start latency. People always ask that, oh, how can I find out backlog on a task queue? Because they want to tie that to how many workers they need to spin fast from the time when it was created. So it is kind of an indirect metric that how much backlog you are accumulating on your task queues. So general recommendation, like if people who wants to have a much more dynamic compute associated, use schedule to start latency metric for auto scaling your workers. These workers are stateless, but I think the other key part is isolation. Think through your isolation, and it's actually kind of linked with the previous question around prioritization also. Make sure you understand if you have dozens of workflow types running in a single, at the very high level, the key isolation boundary that we offer is namespaces. And we provide certain guarantees on a namespace, that all the workload which is running within a namespace should be completely isolated from, we are a multi-tenant system, and it should be completely, we provide guarantees around performance and availability guarantees for a particular namespace. Sometimes I see that guarantee starts breaking apart because of software bugs, like out of, let's say, those 12 workflow types that you are running on that worker, which is pulling tasks from a single namespace, one of them has a bug. And that bug is basically it causes your workers to go out of memory. And I have many times seen that because co-hosting all of those workflow types on a single worker instance starts interrupting your other workflow types, which might be more critical for your business. And so understand the isolation guarantees. At a more higher level, namespace is the top level primitive where we provide certain guarantees. You can play some tricks with task queues to manage your own topology, how you deploy workers. It gives you a little bit better control or more isolation, but it's not as buttoned up as namespace level. And yeah, I think.
Yeah, one other thing I'll add just on the Lambda question, and then we'll move on to the final question before we get on to the next application. Oh yeah, please, Tio.
Just real quick regarding for people that are new, Temporal does not execute your code. your workers execute your code. So that's number one. And just wanted to add that also with Temporal real quick, a workflow execution is not tied to one particular worker. So for the first question, when it says, should I just have one? Yes, you can start with one, but typically you want to have multiple worker processes for resilience. So if one of your worker processes, let's say on a case pod goes down, your workflow executions can continue on other processes and not fail. So that's one of the things is, as far as worker resources go, start with one worker that has all your workflows and activities registered. Try to what we call saturate it, depending on what Samar said. Metrics are very important. It's important that you set up SDK metrics. It's important that you set up server metrics. And there is in combination between these two, the auto scaling part, can be accomplished. Thank you. Sorry.
No, it's great. I got to add two small bits too, because this is like a big topic. So, one, just building on what you said, one of the most common things we say when we'll explain Temporal to other people is, oh, well, Temporal doesn't run your code. Because there's so many things that Temporal kind of assures that strongly implies that, like, therefore you have to run your code with Temporal. But in fact, that's not at all the case. Your code runs wherever you want. As a result, we want to have as many different deployment targets for your code that work well with Temporal. So whether that be like EKS or, whatever, some physical hardware thing, any version of how you deploy your code. In theory, we want Temporal to have you have a good though is serverless, and if I'm which in really it is the nature of because serverless, the process is not up all the time. My understanding is you can wind up with some weird and correct me if I'm wrong, but you can wind up with some weird interactions between that worker process coming up at starting up and stopping in the process of being a serverless function, and the way that the task queue, I think it's the way that the task queues will try to talk to it and won't always hear back. And so it's the one where it's the one that operationally. Okay, Max can do it.
Just first thing, you can easily just write a worker which will just go and call Lambda function, right? Like if you have an activity, you practically write a worker which is a generic worker which will practically just say execute activity, start Lambda. And this worker, you have to run that worker, but it can be very generic. Capacity is very low because it will just go to AWS API using your credentials and start that Lambda. It covers probably 90% of your problems. If you want to run workflow code in Lambda, we could do that. Problem is that Lambda is not very good for caching, right? And workflows we want to cache just for performance. We want to load history every time. So we absolutely can implement easily integration with Lambda, but then it will be inefficient. For very slow workflows and which are running low rate, it would work. As soon as something more high rate, it will be just very expensive. My understanding that these days Lambdas are weird. They have kind of additional state and we can run for a long time. Maybe one day, if somebody is interested in that project, we just don't have capacity for that, talk to us. We can come up with some design and even run, I think, workflow workers there. But it's something which requires some additional engineering. But again, if all you want to do is just run an activity, just write a very simple custom worker which will just start that activity and then maybe get some callback. And probably Lambda function can itself call back into whatever API just to complete that asynchronously because we have this async activity completion.
Well put. So yeah, so there's a lot of nuance for a server, like for Lambda specifically, but other than that, you can kind of think about any deployment target. Okay, last one before we switch over to Atish is, I'm going to do this justice, but this is clearly a question for Dominic. Are there any papers or academic material which underpin the technology behind Temporal, maybe research on workflow engines or distributed sagas or actors and whatnot? Dominic, what's your favorite papers?
There are actually a bunch of papers that I enjoyed reading at my time of Temporal. You know what? I will just collect some of my favorites, and then later today, or depending on how today's goes, maybe tomorrow, and share them on our Slack on the water cooler channel. And then I am pretty sure that collection is going to entertain you for the rest of the year. It's pretty cool.
Yeah, Dominic has an enviable collection of papers, and actually he runs a weekly kind of book club, essentially, on systems papers, which are not always directly about Temporal. They're oftentimes about adjacent topics. But if you want to understand this at like a theoretical and like a systems level, Dominic has an encyclopedic knowledge of the prior art here, and a lot of it dovetails very nicely with the way Temporal's implemented. So there's lots of good stuff to get out of it. So stay tuned for that. Okay, I want to get back to kind of a tangible example. And Atish was kind enough to agree to share a bit of what he's working on at Coalition. Atish, are you able to join us up here? And again, thank you, Atish, for being willing to share your work in progress. Same as last time with talk, I would love to just learn a little bit about kind of Coalition, what the company does, what you do for the company, maybe as a start. You had it? Oh, exciting. Well, you're in good company, Atish. Okay, all right.
Hi everyone, I'm Atish. I'm a backend engineer at Coalition, and Coalition provides cybersecurity insurance, which is like a new kind of insurance. But we're like really excited about it. We are a Series F startup now, valued at $5 billion, and we recently closed a funding round. At Coalition, we provide cybersecurity insurance, and right now we are more focused on active side of it, which means that not only we provide insurance coverage when you have an incident, we also proactively try to like help clients become like more secure and less vulnerable. We have like scanning engines that scan the whole internet and like provide policyholders with emails if they are using like some vulnerable tools or services.
How many folks are on the back-end engineering team at the company?
I think it's like around 100.
All that are back-end alone? Or is that all engineering?
All engineers, I would say.
Okay.
I don't have the exact number, sorry.
No, it's fine. What fraction of that would you say is back-end development?
Like 60, 70%.
That much?
Yeah.
Okay, wow. So your tech stack, maybe you want to talk a little bit about just kind of what the language is and other infrastructure choices?
So we started with Monolith in Python. We still have that running. And now the company has been like growing so fast. We have been extracting out microservices, mostly in Go. So throughout the company, it's mostly Python and Go.
Oh, very cool. We have a meetup downstairs that just, I'm glad we grouped Python and Go together. It sounds like we guessed right. How far are you into your process of using Temporal, if at all?
So Temporal is being used, I would say, like heavily in some of the other teams within the company, like to track life cycle of a policy from being a quotation to like being terminated, things like that. In my team specifically, we started using it to send out emails based on some like prerequisites. And that is one of the things I wanted to like ask whether I'm doing the right thing or not.
Oh, very cool. Before we get to that, I just want to ask you one or two more questions. This actually the same question as what I asked Tony. So if you were to kind of ask a colleague at work, where do you use Temporal? What's the conventional wisdom? Like, what's the hallway advice you'd get on like where it's supposed to be used?
I would say like anything that should not happen on a wave request should go into Temporal.
Very cool. This process of extracting your way out of a monolith, how much time has been invested in that? Like, how far are you into that journey?
So far, like we have extracted out a lot of services, but there's still a big chunk of code in the monolith. That is why it is still living. We are, I would say, like maybe 50-60%.
Cool.
Yeah.
So let's talk about, and it sounds like some of the temporal features in other teams, like policy lifecycle, these are already in production. Is this fair to say?
They are.
Okay, got it. But let's talk about this specific example of this this email feature application. Can you kind of describe it a bit?
Yes, I have a little diagram here. So this is one of the workflow architecture that we have. We have a Lambda that triggers a workflow, and then within the workflow, we handle logic related to renewing a policy. So we determine price and then the status of the renewal, and then we have to communicate to brokers and policyholders based on the result of that workflow run. So we start child workflows, as you can see down below. This is like the high level overview of that.
Very cool. So maybe just to start, let's see here. Let me see, in terms of the functionality, like where was this implemented previously, or is this net new functionality? I guess let me ask this to begin with.
The communication one would be this was implemented previously.
Got it.
Yeah.
Got it. And how far are you into the temporal implementation?
For my specific use case, I basically wrote it 2 weeks ago.
Excellent.
Yeah, this has been running in production for quite a while.
Okay.
Yeah.
Okay. Samar, Dominic, Tio, any clarifying questions before we get into the specifics?
Yeah, can you just what are these blue boxes versus yellow ones? Are these external system? Blue ones are external systems?
They are lambdas, and the blue boxes are external system. We also consider the child workflow as being external to the workflow in context. So yeah.
So this is basically Lambda triggers a workflow, and the yellow ones are the activities this workflow is invoking.
Yeah, that is right.
So it's a good, is it a fair statement to say this workflow has 2 serial steps, then a decision, and then eventually ends up making calls to one of the 3 external systems?
That is correct.
Okay. Cool, makes sense.
So one of the
question is it possible to zoom in a little bit, if we go into presentation mode, it goes poorly, I think, right? Okay, there we go. That's perfect. Thank you.
Does that work? So one of the, I would say decision choices we have to make is whether to do something as an activity or spin up a new child workflow. Do you have any suggestions on that? How to?
It's a great general question. So yeah, so the question is, which piece of, when you do certain piece of implementation of a workflow or a service, when does it make sense to employ an activity? When does it make sense to employ a child workflow? Yes, it was a really good question. Who wants to start with that?
I can take it. For activities, I think it's obvious. Anytime you want to do any sort of operation that is not, let's say, orchestration, which is your workflow code, such as, in this case, invoke the 3 different third-party services, or basically do anything based on system time, or anything that is reading or writing from some sort of persistent storage, or basically any operation where you go outside of orchestration and perform some sort of work that your application has to do, or communication between different systems that it needs to in order to accomplish your goals, you would use an activity. With child workflows, there is really 2 use. Typically in workflow system, you think of a child workflow or a subflow as a reusable component that you can use between multiple workflow definitions that you write. And typically when you think of workflows or subflows, you think like that. With temporal, child workflows actually can have another very important meaning, is that, and it has to deal with some restrictions of the overall number of history or events that you can have in a workflow execution. So child workflows can still be used as some sort of reusable component. However, with temporal, you are dealing with programming languages, so you have programming language concepts of your reusability as well that you can use. but often cases child workflows can be used in order to partition some of those limitations in terms of histories, especially important for long-running workflows, into smaller subsets, and can perform a lot more operations than you typically could perform with a single workflow. So that's another use case for child workflows that you can use.
Thank you. So how do you determine like when to use like a helper workflow function versus create a separate child workflow to reuse certain workflow logic within different workflows?
So reuse is actually not a good use case for deciding whether it should be a workflow or a child workflow. The reason is, and this is one of the mistakes that I sometimes see users making, is the reason we went with this code-based approach for writing your applications is so developers can use any object-oriented techniques to manage the complexity of their application. So you should not have to spin up a new workflow when you are thinking about like, oh, this is isolated piece of logic, and I want it to be separate than basically my main workflow. So you can use your own object-oriented techniques and have reusable components which can be used by all sorts of workflow implementation. I think what Tiho was kind of hinting towards is temporal is a system which scales on number of workflow executions. But a single workflow execution itself has limited scale. And that sometimes you have, I see sometimes users make this mistake that make an activity, like get users, and then it returns, let's say, thousands of users back, and then start spinning up activity like, for each one of those users. That is an anti-pattern. Like it will blow up the history of a single workflow execution. I think the max history that we support is either 30,000 events or 50,000, somewhere around 50,000 events. It's configurable, but anytime you have such a large number of events, you are doing something wrong, essentially. Child workflows could be a good way to solve this problem, because actually that's how one of the ways that we battle test the resiliency of the server is what we have is like a bomb workflow, like a top level workflow which starts 1,000 childs, and each one of them starts another 1,000 childs. Suddenly you have 1 million workflows in the system. And now essentially, so this way where you need to do a lot of processing, child workflows is a good primitive which allows you to do all of that processing spread across multiple workflow executions. So that is one mechanism. Another one is think about the life cycle. The life cycle is, in the case of an activity, is always tied to your workflow. But if you are spinning up a child workflow, it does not necessarily tie to the life cycle of your parent. So that workflow can live on its own, like whatever life cycle, like even the parent can complete and then it can do its own work and then finish sometime later. So that is another place where child workflow might work out. Sometimes I see separate teams, team boundaries is where child workflow starts making a lot of sense, because I have seen many organizations where as people are building microservices, for these asynchronous part of the processing or workflows becomes actually boundaries how different teams talk to each other. So then typically the only way which is available today, which probably I think we'll be talking tomorrow about, we want to introduce a new concept, is people can invoke those services as child workflows as part of their parent. So those are all valid reasons to have child workflows.
Yeah, that makes sense. Thank you.
Very cool. Atish, any other questions that you had from the design point of view or the implementation point of view?
So I'd like 2 questions.
Yeah, please.
And One you just answered right now around like child workflow and how we shouldn't like grab a list and execute a lot of activities at once. So the other question I have is around like sleeping. So one of the workflows, like this is a code that I wrote 2 weeks ago, is like we have to send out emails, and to send out emails we need to wait on certain documents to be generated. So some of them are like required documents, some of them are like optional documents. If they get generated in time, we'll like attach it, otherwise we would not. And for this, I have a for loop, like an infinite loop here, where I'm like sleeping in between each iteration and just checking whether the documents are available or not. And then after a certain time, we give up. So I wanted to get feedback on whether this is like a good approach or not. Like the other alternative I thought about is like putting the sleep in an activity and just receiving the result of that, utilizing the activity timeouts. Yeah, so there are like a couple of ways to go about this, and I wasn't sure like what is the right approach here.
No, it's a great setup, and that's I agree. There's a couple of cases in Temporal. There's more than one way to accomplish it, and there's usually like some reason why you have more than one primitive. But why is that, and how do you apply it? So, who wants to go for this one?
I can't see the code from here, but I assume it's just a for loop with a sleep inside of it. All right, so the sleep actually is a temporal API directive. It is, so workflow is, your workers are going to execute your workflow code up until some sort of quote unquote block. And sleep is one of the blocking APIs where at this point we need to actually help of the temporal server to actually create a durable timer for the amount or the duration that you define in your sleep, right? So at this point, what happens is also temporal server, or two events are going to be written to the history. One is the timer started event, which you will see when your worker executes this code, and then when the durable timer triggers, you're going to see a timer completed, I believe, event. So having some sort of infinite or loops inside of your workflow code that do some blocking API, such as, we're not always blocking, but invoking activity or invoke child workflow. So in this case, sleeps, anything that generates workflow history, having some sort of infinite loop is typically not the best thing you want to do. Because since this is a long-running workflow, you will run into the situation that after hours or days or months of running this workflow, you do again, we have to bring this up, run into some sort of limitations of the history amount. So typically the way we're dealing with this is to, well, before we had to kind of look, okay, how many activities am I invoking in this infinite loop? How many times am I sleeping? We had to usually calculate the number of events, and after, let's say, 1,000 or 2,000 or whatever they define, we would call continuous new, the Samar mentioned, meaning we would continue this execution, which would clear our workflow history, and then we will have all the 50K events again. I think right now with the new server versions, and if I'm wrong, Joe, yes, sir.
I'm just wondering in this case whether Signal would be the best solution. Just Signal on email don't sleep at all.
Yeah. So actually, one clarification on this one is like I'm still looking at the code and trying to understand. So you have a for loop, which makes this is the first like require docs available. Is that like activity where you are checking some precondition? Can you explain this logic a little bit?
Yeah, sure. So at the start of the loop, what we do is like we call an activity. Okay. So I've just extracted out it to like this. So we execute an activity and get the result back. Inside the activity, we actually like go to a database and check whether a row is completed or not. Because of the legacy requirements around like how documents are generated, we don't have a signal right now.
Okay. Okay. So I think now I understand. So it looks like what you are implementing in this workflow is polling logic.
That is correct. Yeah.
Yeah. You are polling for a certain change in your database, and then once it returns success, then you want to run some action.
Yep.
So I think Signal is a very good primitive where you can have a workflow. So like if you have a mechanism, so few things. So looks like the activity. So there are multiple ways you can go about it. So activities itself, rather than putting this code in your workflow, and who knows how long you need to poll, and if you need to poll for looks like every time you are polling after every 10 seconds.
Yep.
And this has the potential, like if this code runs for a very long period of time, it can blow up the history of your workflow execution. So first of all, having this code within your workflow implementation is not a good idea. Because then, although it will work, but then you need to think through all sorts of other concerns around my history sizes and doing things like continue as new, or maybe using child workflows to work around those things. A better way to implement the exact same piece of logic is put it in an activities themselves can be long running. So all you care about is some piece of logic which is making a poll, a call to your database to see for a particular row completion. If that is what you want, you can have a long running activity which heartbeats back to temporal and with whatever frequency. And then within the activity, you can put this loop within the activity, which is it's polling the database. And eventually when it completes, when that poll results returns with a success. So that might be one mechanism where you can achieve that without running into all sorts of other problems if you put the poll logic within the workflow. Another way, which looks like some gentleman was suggesting there, was signals. Yeah. Where you might have an external system which is polling, like looking for those events, and if you have a way that those systems can make a signal call to temporal, then having this code block on a signal from an external system that, oh, now your poll succeeded, now run your activity logic.
The question about what you just suggested. So if we run this poll inside an activity, will that not cause that thread to be blocked forever?
It is. Yeah. So that's why in Java, in Go, yeah. First of all, Go routines are cheap. So probably putting this code, if you are using the Go SDK, I see a lot of use cases where people use it all over the place and it's not an issue. In Java specifically, yes, number of threads are very limited and that activity will block a thread. So so this is where essentially like what signals might be a better recommendation, where you have one system which is doing poll on a batch of all those things, and then sending signals to your workflows.
Go ahead, Dominic.
I would like to actually narrow in on that, because that's super interesting. When we looked at the diagram, remember the blue boxes, where we said this is outside of temporal. Now, obviously we talk a lot about temporal, right? But we also need to talk about temporal in context. So we need to see temporal in the context of the rest of your application. So do spend some time on the design of inbound and outbound calls, right? So to get the end-to-end correctness and end-to-end guarantee. So whoever asked for academic paper, highly recommend the paper End-to-End Guarantees in System Design, a 1983 paper that is just as valid today as it was back then. And if you look at that, for example, the idea of the signal, right? You may have the database and you could set up something like CDC change data capture in order to then transform a change in the database into a signal that goes back to temporal. But can you guarantee that you're going to get it, right? Can you make that guarantee? Can you guarantee you route it to the right workflow execution? So that is very, very important for the correctness of your system. If, as Samar suggested, you put it into an activity and have the activity poll continuously that database, you are actually within Temporal, and you can rely on all of the guarantees that Temporal gives you. So it's going to basically be correct by construction. If you actually decide to go outside the system and then react to the signal, yes, once you can guarantee that the signal goes to Temporal, you will have the correctness guarantee. But you need to make sure that that change actually reaches Temporal as a signal, otherwise the workflow will just block on that.
It's been great. And I want to add, there was one question in the Slido which dovetails with this, because we've mentioned a couple times about continue as new and the number of events and things like this. And the question was, how much data does Temporal spawn internally over a long period of time for active workflows? And I thought it'd be a good time to kind of, obviously hard to give a definitive answer to this, but I think a directional answer will help a lot of people's intuition if you guys want to take a crack at that.
So sorry, Charles, can you repeat the question?
Well, the way the question's asked is, how much data does Temporal spawn internally over a long period of time for active workflows?
It's the...
well, that's how the question's raised, but I think you talked about this issue that when workflows run for a long time and there's a high event count, eventually you're going to take advantage of continue as new. And that's something that does sort of pertain to the data that's held inside of a workflow. And I think it would be worth people understanding how much data winds up in a running Temporal workflow and under what circumstances.
Yeah. So at the core of a system, we use a technique called event sourcing, which means as your workflows are running, any interaction or any action that they are performing is stored somewhere. Any activity, any user timers, any signals that it's receiving, any child workflows that it's invoking. Each one of those represents as its own history events. So we do, as part of your overall workflow execution history, the metadata for those history events is something which is generated internally by the system itself. But the majority of the overall data, which is your application logic, which the input parameters you are passing when you invoke an activity, the result of your activity function, because all of those payloads eventually get serialized and stored as part of those history events. And those are the ones which basically most of the time we should be watching out for. Things which results in blowing up the total execution history size of your workflows which are executing. One thing to remember is we are an orchestration system. We are not a big data system. So look for opportunities where do not pass large amounts of data through Temporal. If you have an activity which needs where you need to pass like megabytes of input parameters, it's much better to pass a pointer, put it into like a blob, all of the data in a blob, and then pass pointers to it, rather than pass the entire serialized megabyte of data through an activity input parameter.
Awesome. All right, we're almost out of time, but Dominic had one more bit he wanted to mention, and then I want to wrap up.
So for me, this is a super interesting use case. I wanna look into sending emails, because that's actually a pretty tricky one, and it unlocks one of the features at Temporal that we usually recommend you not to use. But in that case, you should use it. Okay. So you're sending an email in an activity, right? And if you remember, a Temporal workflow execution gives you the guarantee that it executes effectively once to completion. And effectively once means it's observably equivalent to exactly once. But to give you this guarantee, we need your help. Activities need to be idempotent. Many activities can be made idempotent, but sending an email Now that's a super tricky one, right? Is sending an email idempotent? I do not know of any email providers that actually let you specify an idempotency key, right? So, and you need the help, end to end, you need the help of your upstream systems to guarantee idempotency. So if you have an email, you probably don't have idempotency. Now, what are we going to do about this? Temporal may retry your activity. That means that every single time, if in doubt, that activity, sending email, gets retried, you actually may send an email to the user. So duplicating an email is fine, right? Once in a while, we get a duplicated email in our inbox. That's cool. Having hundreds, thousands of them, that's really not cool. So usually, we recommend you just keep retrying, right, as long, time-based, as long as your business process allows. But we also have a maximum attempt. And usually we just say, no, forget the maximum attempt unlimited. If you can retry for 8 hours, retry for 8 hours. Well, not in this case, right? If you send emails, it may make sense to send your maximum attempts to, for example, 2. Because in the worst case, the user may get 2 emails, but not 100,000. So that is an interesting nugget when it comes to emails, idempotence, and the one configuration that we usually say, don't use it, that is maximum attempts. In that case, it may actually make a lot of business sense.
I was going to say, like, we actually use that option a lot just because there are some legacy APIs that we use, which give us like 500 error. But on their end, like, it's like halfway completed, so we cannot like really retry.
Yeah, that is a very tricky problem. Yeah, especially with the legacy systems, that's a very tricky problem.
Wonderful. And we're right at time. We stuck the landing. I want to thank Atish, thank you so much. And Tony, thank you so much for sharing. Standing offer for those of you who join our meetups virtually when we're not together in these kind of conferences. If you like, I feel like the community learns so much from these kinds of examples and this kind of interaction. I know it's a burden on you to have to share in front of a lot of people and put together content, but standing offer, if you want to do this online sometime in the future, where we can share it with other people so that they can learn too, I will assemble this brain trust for you whenever you want it to kind of produce an equivalent kind of experience. So thank you so much for sharing your application. Thank you to the panelists, and thank you for coming. Lunch is downstairs.
Awesome.